Yeah. Hey, sorry you. I need to. Are we ready now? Yeah. All right. Good day, everyone. My name is Folarami Israel Olaoluwa. So this is Free Success Project 2026, and then is an initiative by CMRC, Creative Mind Real Concepts. So I'll be taking you guys chemistry, and then the aspect of chemistry that I'll be talking about is electrochemistry. And then the most important part of electrochemistry that I'll be doing today is electrolysis. So let's start with electrochemistry. What is electrochemistry? So as the name implies, you can see electro and chemistry. So chemistry deals with the study of something scientific, and then electro, that one comes from electricity. So we are basically studying electricity. Now, what is electrolysis? So electrolysis is also, as the name implies, too, you have electro, you have chemistry, you have electro, and then lysis, sorry. So lysis has to do with breaking down or decomposition, and then electro has to do with electricity. So electrolysis is the chemical decomposition of a chemical compound, which is an electrolyte. So the chemical compound that is undergoing decomposition is the electrolyte. So electrolysis is the chemical decomposition of an electrolyte in molten state or aqueous form. Electrolysis is the chemical decomposition of an electrolyte in molten state or aqueous form by the passage of electricity or electric current. So an electrolyte in molten form or aqueous form decomposes and gives its ions when electric current or electricity is passed through it. Now, so that will lead us to what we call electric conduction. So conduction of electricity. Now, a substance that is able to conduct electricity is what we call a conductor. A conductor is a substance that is able to conduct electricity. Now, insulators are those substances or materials that they don't allow electricity to pass through them. So in electrolysis, we'll be talking about electrolytes. Very important thing. So what is an electrolyte? An electrolyte is a chemical compound in molten state that can decompose and give rise to ions. Now, to continue, there is what we call electron carriers. Electron carriers are those means by which electrons are being transported. So, and then I'll be giving you guys examples. Now, I told you that a conductor is something that can allow electricity to pass through it. It can allow the passage of electricity. Now, let's talk about electron carriers. So I'll be talking about electron carriers in conductors and then electron carriers in electrolytes. Also, there's an important point, semiconductors. Semiconductors are like the ones in the middle between conductors and insulators. So from the word semi, like semiconductors. Now, let's talk about electron carriers in conductors, electron carriers in semiconductors, and electron carriers in electrolytes. Now, if you have a conductor, you have, let me put here, we have conductor, then we have semiconductors, and then we have electrolytes. Now, electron carriers. Let me call it, okay. Let's call it electricity carriers. That's the correct form. Electricity carriers. Now, what are the electricity carriers in conductors? They are what we call the electrons. Electrons. In conductors, electrons are the electricity carriers. Now, in the semiconductor, what are the electricity carriers? We call them electrons and holes. Electrons and holes. And then in electrolytes, the electricity carriers are what we call free mobile electrons. Free mobile electrons. So if you have an electrolyte and then you pass electricity through it, ions will be released. Then it is now those ions that will be carrying electricity. For conductors, what will be carrying electric current? Electrons. And then for semiconductors, you have what? Electrons and holes. So that's like a very common JAMB question. Now let's move forward. So in electrolysis, our main focus is the electrolyte. Now let's go further. So from what I put here, I've divided electrolysis, electricity conduction, and then all this. Now let's go to what we call electrolytic and electrochemical cells. So we have basically two types of cells. We have the electrolytic cell and the electrochemical cells, and then there are differences between the two. An electrolytic cell is a kind of cell whereby the end product, whereby we use an external force, something like electricity, to generate chemical energy. Conversion of an electrolytic cell converts what? Electricity to what? To chemical energy. It converts electrical energy to chemical energy. While an electrochemical cell, that one converts chemical energy into what? To electrical energy. So electrolytic cell converts electrical energy to chemical energy, while electrochemical cells convert what? Chemical energy to what? Electrical energy. So examples of electrochemical cells are our normal cells, these ones that we are familiar with, our batteries, whether our car batteries, our touch batteries, our phone batteries, and the likes. Now, what are electrodes? Now, I would like to draw the structure of a typical cell for us. Let me just draw the structure for an electrolytic cell. Let me draw this for us. If you look, this is what it looks like. Now we have this. Okay. Movement, then current movement. Now, this is a typical example of an electrolytic cell. This is a typical example of an electrolytic cell. What are the things that we can observe here? So we have a compartment. In that compartment, we have the electrolyte. The electrolyte is that portion, that liquid form here that we see here. And then it's capable of breaking down. It's always in molten state. It's always in molten state. So let us pay attention to the state of whatever the electrolyte they are talking about. Now, so in this compartment, we have the electrolyte. That's what is there. You see it with all these dashes. Then we have the electrodes. Electrodes are the terminals that we have in a cell, whether electrochemical or what, or electrolytic. And what do electrodes do? They help in the movement of ions. They help in the movement of ions and electrons throughout the cell. Now, basically, in a chemical cell, whether electrolytic or electrochemical, we have two types of electrode: the anode and the cathode. The anode and the cathode. Now, the anode is that part of the electrode. The anode is that electrode where oxidation takes place. Oxidation takes place at the anode in all cases, whether electrolytic or electrochemical cell, while reduction takes place in the cathode. So in electrolysis, we will find a way of doing a kind of merging of redox reactions and electrolysis. So I can combine the two. Now, so from what I wrote here, we can see CRAO. This is CRAO, and then this is an acronym that I can use to quickly remember: cathode reduction, anode oxidation. So when we are talking about differences between electrochemical and electrolytic cell, now you'll be saying that in an electrolytic cell, anode is the positive electrode, while cathode is the negative electrode. In an electrochemical cell, the reverse is the case. So in an electrolytic cell, anode is the positive, cathode is the negative. But in an electrochemical cell, anode is the negative electrode, while cathode is the what? Positive, while cathode is the positive electrode. However, oxidation occurs at the anode in both cases, whether electrolytic or electrochemical, and reduction occurs at the cathode. Now, what is oxidation? Oxidation is the process of loss of electrons. It's the process of electron loss. Reduction is the process of electron gain. Reduction in the presence of electron gain, oxidation in the presence of electron loss. Now, what is an oxidizing agent? An oxidizing agent is an agent that causes reduction. Sorry, an oxidizing agent is an agent that causes oxidation, while a reducing agent is an agent that causes what? Reduction. An oxidizing agent is also known as oxidant. A reducing agent is also known as what? Reductant. So we need to know this. Oxidation, process of electron loss. Reduction, process of electron gain. An oxidizing agent gains this electron. However, in a redox reaction, an oxidizing agent becomes reduced, while reducing agent becomes oxidized. Now, so that's the way it works. So at the cathode there is reduction, and then at the anode there is what? Oxidation. Now, that is to say, if you look at this simple electrolytic cell now, we can see that the anode is here. So this is the anode here, connected to the electrolyte. We can see the way electrons are moving. Because oxidation occurs at the anode, and oxidation is the process of loss of electron. That means electron leaves the electrolyte through the anode. Because oxidation is electron loss. And the oxidation is the process of loss of electron, and then oxidation occurs at the anode. Meaning that electron leaves the electrolyte at the anode. Why? Electron enters the electrolyte through the cathode, because cathode is the process of gain of electrons. So electron enters the electrolyte through the cathode. Now, so the movement of the electrons and current, they are opposite in an electrolytic cell. So electrons leave the electrolyte through the anode, and then current enters the electrolyte through the anode, like opposite direction. The way the electron leaves, the part where the electron leaves, that's where the current comes in. So electron leaves the electrolyte at the anode, while current enters the electrolyte through that anode. Now, electron enters the electrolyte through the cathode, and then current leaves the electrolyte through the cathode. So that's the way it works. So we should know that although anode is positive, anode is the positive electrode, positively charged in the electrolytic cell, but it is negatively charged in the electrochemical cell. Likewise for our cathode is negatively charged in the electrolytic cell, but positively charged in the electrochemical cell. This does not change the fact that oxidation occurs at the anode and reduction occurs at the cathode. So that's that about that. Now let's go to Okay, now I want to define like electrolytes. Under electrolyte, we can have different types of electrolytes. We can have the strong electrolytes, and we can have the weak electrolytes. Just as we have in acids and bases and salts, weak acid, strong acid, weak bases, strong bases. Now, what is a strong electrolyte? A strong electrolyte is an electrolyte that ionizes completely in aqueous solution or molten form to liberate ions. A strong electrolyte is an electrolyte that does what? That ionizes completely in aqueous form or molten form to liberate ions. Now, what are examples of strong electrolytes? Examples of strong electrolytes are our mineral acids. Our mineral acids like HCl, hydrochloric. Don't forget that they must be in aqueous states. So, for example, if I'm saying HCl now, I'm not saying HCl like this. I mean, it must be in aqueous form. HCl. So this is the electrolyte now that we're talking about. Now, say if I'm saying sodium chloride now, if I say NaCl solid, this will not conduct electricity in this solid state. It is not an electrolyte in this form. But when it becomes NaCl aqueous, we see AQ into brackets subscript. This one is the one that can conduct electricity. So be mindful of the options that they give in your exam. Make sure you check the state. It must be in aqueous or molten form. That's when it can be an electrolyte. Now, let's continue. So strong electrolytes are those that can ionize completely in solution to liberate your ions. Ionize completely. Examples: mineral acids like our hydrochloric acid, tetrasulfate 6 acid, all those strong acids. HNO3, that's hydrogen triazonitrate 5 acid and the likes. Also our caustic alkalis. Caustic alkalis like sodium hydroxide, like potassium hydroxide. They are very strong. So those ones, they can ionize completely in solution to liberate our ions for us. Now, and also another category of strong electrolytes is our salts. Our salts. Sodium chloride, aqueous, molten form, a strong electrolyte. Potassium chloride, KCl, a strong electrolyte. You have ammonium chloride, strong electrolyte like that. Now let's go to our weak electrolytes. Weak electrolytes are those electrolytes that they ionize only partially. Now let's watch this. When I was talking about the strong electrolyte, let's say I give you this. NaCl is a strong electrolyte. When it wants to ionize, you'll be seeing a straight arrow like this, complete. This is the symbol, straight. So you have your ions, Na plus Cl minus, both of them aqueous, sodium ion and then chloride ion. But for weak electrolyte, how did they ionize? They ionize only partially. Now, this is the way it is. It's a symbolized, let's say, okay, let me use a weak electrolyte. An electrolyte like water. Now, examples of weak electrolytes, we have our organic acids. That is to say, I'm talking about organic compounds. Acids like our arachidonic acid, our carboxylic acid, acids like methanoic acid, ethanoic acid, our propanoic acid, all those acids, they are weak. Organic acids, they are weak. Also, there are some bases that are weak. Bases like ammonia, bases like sodium, thiazocarbonate, 4Na2CO3, and then we have our water too. Water is a weak electrolyte too. Now, let's say I have this. Let's use water. Water is H2O. Water is a weak electrolyte. How does it ionize? Now, look at it. You see that